With the next chapter, which is chapter 4, and this is on matrices. Okay, so last semester you already did matrices, so we're not going to repeat those topics that you did, like Kramer's rule, how to work out the determinant. Those are things that you should know. If not, you have your notes from last semester, you can read up on it. So today, what we will, just give me a minute. Okay, so what we are going to do today is solve equations. And instead of using Kramer's rule, which you know, we are going to use something that we call Gauss elimination, or Gauss elimination, however you want to say it. Okay, so that is what it's called. And the way it works is if you're given an equation, for example, this one, we have 2x plus y plus z is equal to 7, 4x plus 4y plus 3z is equal to 21, and then 6x plus 7y plus 4z, and this is equal to 32. So if we have a system of linear equations and we have to solve them and work out the value of x, y, and z that satisfy all three of these equations. Now, one thing you should know about the Gauss elimination is that it's very simple. It isn't very difficult. The only thing is it is very easy to make a mistake because there's a lot of mini calculations that you are doing. And once you make a mistake at step 1, it affects everything you do at the steps after that. And sometimes to check and see what it is you have done wrong, you have to go over everything again. So that can be quite tedious. So try and be as careful as possible when using this. Now, the way we solve this is we come up with what is called an augmented matrix. Okay, now this augmented matrix has one part which is made up of the coefficients. So first of all, notice that this equation is given to me in this system rather is given to me in the way that we want to. See, the x's are lined up, the y's are lined up, and the z's are also lined up. So if your system is not given in this format, the first thing you should do is write them in this way. Your x's together, the y's together, the z's together, and all the constants on the other side. Then you come up with the first part of the matrix, which is made up of the coefficients. So you can see I have 2, 1, 1. So I put 2, 1, 1. And then the next row, I have 4, 4, 3. Then the next row, I have 6, 7, 4. Then we draw a line here to distinguish this part of the matrix from that one. In your notes, it's not there, but I find it quite confusing when it's not there. But the line there is just for us to distinguish one part of the matrix, that these are the coefficients, and then on this side we have the constants. So we have 7, 21, and 32. So this is my augmented matrix, and from my augmented matrix I can always go back and rewrite the system. So it's 2x plus y plus z is equal to 7, 4x plus 4y plus 3z is equal to 21, 6 x plus 7y plus 4z is equal to 32. Okay, so now what we do is we perform what we call elementary row operations. So these are elementary row operations. Now these operations, the first one is you are allowed to swap rows. So you can swap rows if that is convenient to you. Sometimes you may want to, so you could take row 1 here and make it row 3, and then row 3 becomes row 1. And you can see with equations, the order that I write these equations in doesn't matter. So I could write this equation first, then this one, then that one. It doesn't change the values of x, y, and z. So here, even in the matrix, in the augmented matrix, I am allowed to swap the rows. Then what you can do, another operation that you can do is you can add and subtract constant multiples of rows. So you can add and subtract constant multiples of other rows. Okay, so that means if I wanted to, I could multiply row 1 by 5 maybe, and then add it to that row, and then that becomes my new row 2. Okay, so again, we'll see where we are trying to go, and then you will decide what is the best thing to do in order to get there. And then you can also multiply or divide rows by constants. Okay, so if I wanted to, this entire row, I can divide it by 2. This entire row, I can divide it by 4, and so on. Okay, so again, like I said, there's a lot of little calculations that we are doing. So just make sure that you are not making any mistakes. There's one mistake anywhere in the matrix affects your answer going forward. Okay, so our aim here with Gaussian elimination is to get the identity matrix on this part of the matrix. So we want 1, 0, 0, 0, 1, 0, 0, 0, 1. So that is our identity matrix. So we want these numbers to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and you can see this matrix here in red. That is our identity matrix. And then when we have that, you can see that means I have 1x plus 0y plus 0z is equal to whatever number I have here. So if I have something like this, x plus 0y plus 0z is equal to 3 maybe, then I've solved the first part, or the first variable, and I can say x is equal to 3. And the same thing here, if this is 0, so I have 0x plus 1y, which is y, plus 0z let's say this is equal to 7, then I can already see that y is equal to 7. And then the same thing with the last one, 0x plus 0y plus z. I will have z is equal to 10, maybe, whatever number I have over here. So when we can rewrite our matrix in that form, then we can just read what the values of x, y, and z are from the matrix. Okay, so let's look at this one here and actually work it out. So we want to make numbers 1, 0, and 0 here. So what we can do is with row 1, we can divide row 1 by 2. So we can say this row 1, we are going to divide it by 2. So if we divide the entire row by 2, you can see here I'll have 1 half 7 over 2. The first number here is the 1 which I want, so I'm in the right track. Then if I look at this row here, and then I want to make this number 0. Usually we start making the zeros like this. Make this 0, make this 0, make this 0, then you make this one 0, this one 0, and that one 0. Okay, so now I want to make this 4 a 0. How can I do that? I see that if I multiply row 1 by 2, just the way it is before I divide by 2, and then subtract it from this row. So I'll have 4 minus 2 times 2, which is 4. So I have 4 minus 4, I will get a 0. And then I can work on getting this one, making this one a 1. That's easy because as long as I have a 0 here. And then this one over here, I can see if I use row 1 as well, I can say row 3 minus 3 times row 1. That will give me a 0 here. So here, what I will say is row 2 minus 2 times row 1. And then this one, I will say row 3 minus 3 row 1. And in the test, I want to see this working so I understand what it is you did. And there isn't one specific way to do it. Like the first step is always divide by 2 here. There's several ways that will lead to the same answer. And if both of us have done it in different ways, but all our calculations are correct, we will get the same X, Y, and Z. Okay, so somebody might decide their first step is to swap row 1 and row 2, and then you can do it in several ways as long as you're using any one of these elementary row operations. Okay, so let's see what we get after this. So we said the first row we'll divide it by 2. So we will get 2 divided by 2 is 1. 1 divided by 2 is half. And then 1 divided by 2 again is half. And then on the other side, I have 7 divided by 2, which is just 7 over 2. Okay, then the second row, we said we are going to multiply first row by 2 and then subtract it. So it'll be 4 minus 2 times 2, 4 minus 2 times 1, 3 minus 2 times 1, 21 minus 2 times 7. Okay, so the first one will be 0. Then 4 minus 2 times 1 is just 2. Then we have 3 minus 2 times 1 is 1. 21 minus 7 times 2, that is 7. And then the third row, we said row 3 minus 3 times row 1. So we say 6 minus 3 times 2, that is 0. And then 7 minus 3 times 1 is 4. 4 minus 3 times 1 is 1. 32 minus 7 times 2 is 11. So this is our matrix. So we're in the right way, because now I have 1, 0, 0. Now I need to make this one here a 0. Okay, and you can see I can make this one a 1 already by dividing everything by 1. So I'll divide this one, sorry, dividing by 2. So I'll divide it by 2, but then before I divide it by 2, this row here, I will say row 3 minus 2 times row 2. So I have 4 minus 2 times 2, that will make a 0 over here. So this row, I will transform it as row 3 minus 2 times row 2. So the first row, I haven't done anything to it, so it must remain the same. So I have 1, a half, half, then 7 over 2. Then this one, so it will divide it by 2, so it's 0, 1, a half, 7 over 2. And then this, to get this one here, we said 0 minus 2 times 0 is just 0. 4 minus 2 times 2 is 0. 1 minus 2 times 1 is minus 1. And then 11 minus 2 times 7, that is negative 3. Okay, then here I can see that this number, I can easily make it 1 by dividing the entire row by negative 1. So this row here, I'm going to divide by negative 1. And remember, when whatever calculation you do, you must write it down so that when I'm marking, I can follow along with what you did. So what the matrix you will now get is this one here. Let me see. Okay, we can also, instead of just doing one calculation here, we can make this one as 0 now. Or maybe let's just do it and see what we get. So I have 1 half half, 1 half half, and then 7 over 2. And then 0, 1 half, 7 over 2, and then we have 0, 0, 1, 3. Okay, so here we're not done, because remember we want 1, 0, 0, 0, 1, 0, 0, 0, 1. But you can see that even if I stopped here, I can still figure out what x, y, and z are easier than the equation. Because if I look at the last, then the system that we started with. So here in red, I'm just illustrating something, but we're not done with the Gauss elimination. So you can see I have 0x plus 0y plus z is equal to 3. This means that z is equal to 3. And then here I have 0x. So this is 0x. 0x plus y. So I have y plus a half z. This is equal to 7 over 2. I worked out z here, so I can substitute it here. So I would say y plus a half times 3 is equal to 7 over 2. And then I would solve for y and get 2. So this would be negative 7 over 2 minus 3 over 2, which is 4 over 2, and you get y is equal to 2. And then Same thing with the last one. I have x plus half y plus a half z. This is equal to 7 over 2. I know what z and y are. I can substitute them in there and then work out x. So we have x plus a half times 2, a half times 3. This is equal to 7 over 2. Then we get x is equal to 7 over 2 minus 3 over 2, which is 4 over 2 minus 2 over 2, which is 2 over 2, and this is equal to 1. So you can see that once I have a triangular matrix over here, I can stop and work it out, but without Gauss elimination we will continue until we have 1 0 0 0 1 0 and 0 0 1 here. Then we can just read x is equal to this, y is equal to this, and z is equal to this. Okay, so this matrix here, we will now continue. Let me copy it. Okay, so now we want to make a 0 here and a 0 over there. So what I can do here is multiply this last row by a half and then subtract it from that one. So I say row 2 minus half row 3. And the same thing here because the numbers are the same. So I just say row 1 minus a half times row 3. Okay, then the new matrix I get is 1 minus half of 0 is just 1. Half minus half of 0 is just half. Then half minus half of 1, this is 0. And then 7 minus 3 over 2, that is 4 over 2, which is 2. And then here 0 minus half of 0 is just 0. 1 minus half of 0 is 1. Half minus half of 1 is 0. And then 7 over 2 minus 3 over 2, this is 2. And then we didn't do anything to the last row, so it remains the way it is. So I have 0, 0, and then 3. Okay, so we're almost there. We only need this number here to be a 0. So to do that, I can just say this is row 1 minus half of row 2. Minus a half row 2. Okay, so I have 1 minus half of 0. This is just 1. Half minus a half is 0. 0 minus 0 is 0. And then 2 minus half of 2, this is 1. And then the second row, I didn't do anything to it, so it must remain the same. The last row, I didn't do anything, it must remain the same. So from here, I can see that x is equal to 1. Because I have 0x, y plus 0z, that just means y is equal to 2. And here, z is equal to 3. Which is exactly what we got over here. X is 1, y is 2, z is 3 when we stopped halfway. And as always, substitute your answers back into the original equation and see that they do in fact satisfy it. So it's 2 times 1 plus 2 plus 3. The answer is 7. 4 times 1 plus 4 times 2 plus 3 times 3. It's 21. 6 times 1 plus 7 times 2 plus 4 times 3. The answer is equal to 32. So we have solved this system of linear equations. Okay, so like I said, you can see that the calculations not very difficult. Do them on your calculator to be sure that you don't make any mistakes, but keep in mind that one mistake, if I made a mistake over here, it affects the number over here, and if I use that row to work out another row, it'll affect that row, and it's like what did they call the snowball effect? Everything after that is wrong. And I know the pressure in a test, you don't even know where to start checking to see whether what the mistake you made was. So just be careful when you're working this out. Okay, so let's look at another question where we also use the Gauss elimination to work out or solve the system of linear equations. So we have w plus x plus y plus z. This is equal to 3. We have w plus x plus y minus z. This is equal to 5. W plus x minus y plus z. This is equal to minus 1. W minus x plus y plus z. This is equal to 1. So we have to solve this using Gaussian elimination. So first thing we need to do is write the augmented matrix. So you can see here all our coefficients are equal to 1 and minus 1. So we write it like this. So the first row, 1, 1, 1, 1. Then this line here. Let me draw it with a different color. Three. Then we have 1, 1, 1, minus 1, 5, 1, 1, minus 1, 1, minus 1, 1, minus 1, 1, 1, 1. Okay. Okay, so even though I didn't mention it for this one, remember that if the equation or the system that you are given the variables are not lined up nicely like this, you must align them. Put your W's in one column, your X's in one column, your Y's in one column, and your Z's in one column. Okay, then you have this side, which is your coefficients, and then this side, these are your constants. Then remember the aim. I want 1, 0, 0, 0, 0, 1, 0, 0, and so on. So this side here, I need an identity matrix. So there's already a 1 here, so I don't need to do anything there. I just need to make these 3 zeros. So to do that, I can just use row 1 for all of them. I say row 2 minus row 1. This one, I can say row 3 minus row 1 as well. And then row 4 minus row 1. Okay, then you work it out. So the first row, nothing has changed, so it's 1, 1, 1, 1. Three, and then I say 1 minus 1, this is 0. Then 1 minus 1, this is 0. 1 minus 1, this is 0. Then minus 1 minus 1, that is minus 2. And then 5 minus 3, this is 2. Okay, same thing with the next one. 1 minus 1, this is 0. 1 minus 1, this is 0. And minus 1 minus 1, this is minus 2. Then 1 minus 1, this is 0. And then minus 1 minus 3, this is minus 4. Same thing with the last row. 1 minus 1, 0. Minus 1 minus 1, minus 2. 1 minus 1, 0. 1 minus 1 is 0. And then 1 minus 3 is minus 2. Okay, so you can see that we're almost in the form that we want, except here we want a 1, there we want a 1, and over here we want a 1. So I can see that if I swap this row here with that one and then divide both of them by minus 2, I will have the matrix in the way that I want. So I'll divide all the rows by -2, or the other ones divide by -2. And then I will swap row 2 and row 4. Or you can say interchange row 2 and row 4. So you can see when I divide this row by -2, I'll have 0, 0, 0, 1, minus 1, 0, 0, 1, 0, 2, 0, 1, 0, 0, 1. And then I swap. This row becomes the second row, this one becomes the fourth row. So what I have is this. I have 1, 1, 1, 1. And this is a 3. Then I have 0, 1, 0, 0, 1, and 0, 0, 1, 0, 2, 0, 0, 0, 1, minus 1. Okay, so you can see row 2 and row 4 were swapped, and all the rows were divided by -2. Okay, now we want to make these numbers here zeros. So I can start by saying row 1 minus row 4. Give me 1. So I'm saying 1 minus 0. That's where I get the 1 from. 1 minus 0 again is 1. And then 1 minus 0, 1, 1 minus 1, 0. And then 3 minus -1, which is 4. Then the other rows have not changed. Okay, so now I need to make this one 0. So I will say row 1 minus row 3. So 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 1 is 0, then 0 minus 0 is 0. Then now that I don't have 1s there, I can just use a black line. And then 4 minus 2 is 2. And then the other ones have not changed. Okay, then to make this one a 0, I just say row 1 minus row 2, and this will give me 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 0 is 0, 0 minus 0 gets 0, and then 2 minus 1 is 1, then everything else remains as it is. And we have 0, 0, 0, 1, minus 1. Okay, so now we have our identity matrix over here. Then we can just read what our variables are. So the first row is w plus 0 plus 0 plus 0 is equal to 1. So this means w is equal to 1. Then we have 0 plus x plus 0 plus 0 is equal to 1. This means x is equal to 1. And then from the third row, we have 0 plus 0 plus y plus 0 is equal to 2. So this means y is equal to 2. And then the last one, z is equal to minus 1. And then, as always, substitute these back into the original equation and see if the answer you got is in fact correct. Okay, but again, be careful with your calculations, especially when you have a lot of variables. It's very easy to make a mistake. We have time for one more. Number 3, we have to solve the system of linear equations. Says 3x minus 2y plus 2z is equal to 10. Then x plus 2y minus 3z is equal to minus 1. Then 4x plus y plus 2z is equal to 3. Okay, so the procedure is the same. First, you need your augmented matrix. So you draw it. This is 3 minus 2, 2. And then we have 1, 2, minus 3, 4, 1, 2. Then here I have 10, minus 1, 3. Like that. Okay, so 3 minus 2, 2, 10, 1, 2, minus 3, minus 1, 1, 2, 3. Okay, so it's correct. Then remember what we want to do. We want to form an identity matrix on this side. So this will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So what we can do is we can say 3 times row 2 minus row 1. So I'll multiply this row by 3 and then subtract row 1. So here you can see I have 1 times 3, which is 3 minus 3. That will give me a 0 here. And then for this next one, I will say for row 3, minus 4 times row 2. So I'll multiply row 2 by 4 and then subtract it from here. So I have 4 minus 1 times 4. This will give me a 0 here like I want. Okay, and remember that is before I've done this operation. So when I do that, the first row remains as it is. Then this row here, we said we multiply by 3 and subtract. So it's 3 minus 3, which is 0. And then this is 6 minus negative 2, which is 8. And then negative 9 minus 2, which is negative 11. And then negative 3 minus 10, which is negative 13. And to get this row here, we said multiply this row by 4 and then subtract it. So it's 4 minus 4, which is 0. And then 1 minus 8, which is minus 7. 2 minus negative 12, which is 14. And then 3 minus 4. 3 minus negative 4. It's 3 plus 4. Yeah, okay. So it's 3 minus 4 times negative 1, which is 3 plus 4. Yeah, that's 7. Okay, so here I can see that I can just divide row 3 by negative 7. So I can divide this one by negative 7. And yeah, let's see what we get. So this is 3 minus 2, 2, 0. So 0, 8, minus 11, 0, 1, minus 2, and then this is minus 1. Okay, then I want to make a 0 here. So I will say this is 8 times row 3 minus row 2. Okay, so the first row will not change. So this is 3 minus 2, 2. Then we get 0 there. Then the second row doesn't change, so it's 0, 8, minus 11, minus 13. Then 8 minus 8 is 0, so this is 0, 0. Then minus 16 minus negative 11. This is minus 5. And then the last one, we have minus 8 minus negative 13. This is 5. I'll just take this last matrix to the next page. Okay, so there is our matrix. 3 minus 2 to 10. I get a 0 there. Yeah, see that here, this should be a 10, not a 0. should be a 10. There should be a 10 because I didn't do anything to row 1. Should be a 10 here just to distinguish them. Okay, so again, be careful. Okay, so here we can, the last row, we can just divide it by -5. So first row unchanged, we have 3, -2, 2. Then 10, we have 0, 8, -11, -13, 0, 0, 1, -1. Okay, so now I want to make this one a 0 and that one is 0. So this one, I just say row 1 minus 2 times row 3. And then here I can say row 2 plus 11. This is 11 times row 3. Okay, so row 1, this is what it will become. I have 3 minus 0, which is 3, minus 2 minus 16. Minus 2 minus 16. Sorry, I'm using the wrong row. So it's minus 2 minus 0, which is minus 2. And then 2 minus negative 2 minus 2. This is 0. Okay. And then 10 minus I have -2 times -1, which is +2. So this is just 10 plus 2. So this is 12 here. And then for this one here, I have 0, because it's 0 plus 0. Then 0, not 0, 8 plus 0. This is just 8. And then minus 11 plus 11, which is 0. And then minus 13 minus 11. So minus 11. Okay, that gives minus 24. And then the last row, nothing has changed. Okay, then we can see that this row here, I can divide it by 8. So I have 3 minus 2, 0. I have 12, 0, 1, 0, minus 3, 0, 0, 1, minus 1. So I want to make this one here I want to make it a 0. So I should multiply this row by 2 rather, and then add them together. So this row here, I should say row 1 plus 2 times row 2. So 3 plus 0 is 3, minus 2 plus 2 is 0, 0 plus 0 and then 12 plus -6, which is 6, and then 0, 1, 0, 0, 0, 1, -3, -1. Then this last row, I need to divide it by 3. So you can see I'll have 1, 0, 0, 2. Okay, so that will give me 1, 0, 0, 0, 1, 0, 0, 1. Then we have 6 divided by 3, which is 2, and then -3, -1. Okay, finally. Then from here we can see that we have x plus 0 is equal to 2, so this means that x is equal to 2, and then y is equal to -3, then z is equal to -1, and then you are done. So as you can see, it's basic algebra, because we're just adding usually small numbers or multiplying them by small numbers and then combining them. We're not doing anything difficult. The tricky part is just not getting mixed up or getting your calculations wrong, because once that is wrong, one row is wrong. If you use that row again, it affects all the other rows after that. So just be careful when doing that. Okay, so we'll stop here for today. Tomorrow we'll look at what we call the rank and the basis of a matrix. Yeah. And yeah, that's where we'll continue tomorrow. So remember, the test is on Friday. I think the time is